So in this question, first of all, let's see what it is saying. That the length of a metallic wire are L1 and L2 when the tension in the wire are T1 and T2 respectively. What is the natural length of the wire? Okay, see, first of all, what should be the natural length? How will we find it? There are two formula. One, you can use the strain, right? That is change upon the actual length, right? That is del L upon L. Or where will you find the natural length? There is one more thing where you can find the natural length, and that is in the Young's modulus. What is it? That is F L upon A del L. Now, why are we making it complicated and using this formula when we can only use del L upon L, that is of strain? Because in this question, tension is also given to us. That's why we are using this. Okay, now there are two wires. The one is with length 1, and in that condition, when the wire's length is L1, then the tension which is applied is T1. So if I make one formula for the wire 1, in that case I will write Y Young's modulus is equals to tension 1, original length will be L. We have considered it as L. Okay, let's say because this is original length L, so L is original length. Then the area. And now, what should be the value for this L1? This length should be like, let's say you have an original length, or let's say this is the wire, and now you are applying tension in it. If you are applying the tension, what will happen? The length of this wire will be increased. Let's say it has been increased with a small length, that is del L. And this del L, we have to write about this del L. So this del L, we can also say that if the original length is L and the new length is L1, in that case we can say that what is del L? This is nothing but L1 minus L. This will be the value for del L, complete length, and we can place it over here. That will be L1 minus L, and this will be the value for the first wire, that was L1 wire. Now let's move to the next one, that is the wire L2, which tension is applied in it? T2 tension is applied in it. Let's do for this one now. So for first of all, Young's modulus, what is tension? Tension is T2 this time. What is the original length? The original length is going to stay same, that is capital L. What about the area? Area, see, area is, they are not saying that the nature of wire is different and everything. So area will be also same, that is A. They are not mentioning it is different. Now, what about the length? This time the tension is T2 and the length is L2. Again, it is tension, so obviously the length will be increased, right? So, for example, if this is original length L, then it has been increased a little bit, right? It has been increased, let's say this much, and this time the del L is this. Okay, the del L value is this, let's say del L dash, and the new length which is formed is L2. So what will the value for del L dash? Let's say it should be equals to L2 minus L1, which I can L2 minus L, which I can write over here. That will be L2 minus L. Okay, and what if it was not a case of the tension? Instead, it was a case of the compression. In that case, we would have written original length minus the change, because the change will be smaller than. Okay, so these are the two values which we are getting. Let's say first, and let's say the equation number second. Now, the metallic wire is same in these cases. So if the material is not changing, in that case, we can say the Young's modulus is also not going to change. Hence, these two Young's modulus are equal. If these two Young's modulus are equal, we can equate these two equations. We can equate equation 1 and 2. Let's equate them. If you will equate them, you will find T1 L upon A, then L1 minus L should be equals to T2 L upon A, L2 minus L. We need to find the value for L. If you want to solve for the value for L, first of all, we can cancel out the things which are on the same side. So we can say the numerator capital L can be cancelled out and the denominator A can be cancelled out. Why? Because this is in the denominator, it will go on the numerator. So it will be A by A, which can be cancelled out, and this L will be going in the denominator. There is already a L in the numerator, so that will be also cancelled out. So what we will be left with, technically, we will be left with T1. Oh, sorry, this box come up. So we will be left with T1 upon L1 minus L. And on this side, we will be left with T2 upon L2 minus L. Other things are being cancelled out. Now when you will solve it further, you can take this value, like you can cross multiply it. If you will cross multiply it, you will get T1, and this value will be L2 minus L, and on this side you will get T2, and you will be having L1 minus L. Now you can multiply them, right? You can multiply like T1 L2 minus, so it will be T1 L2 minus, it will be T1 L, which will be equals to T2 L1 minus T2 L. Now what you can do, you can also do one thing now, that you can take the L and L on one side, right? The capital L values on one side and rest of the values on the other side. If you will do so, what you will do, you have T1 L2 on one side, and you can take this T2 L1 on this side, so it will be equals to, okay, we can write that it will be equals to L T2 minus L T1, which will be equals to L1 T2 minus L2 T1. We have taken the different L's on one side, because it's change we have taken on one side, and the capital L's we have taken on other side. Now amongst this equation, we see L we can take common because L is constant, so we can take L common, and we can write T2 minus T1. And on this side, what we will write? On this side, we cannot take anything obviously common, so we will simply write L1 T2 minus L2 T1. Now further what? We have to find the value for L. See, it is very simple now. You just find the value for L. It will be L1 T2 minus L2 T1 upon T2 minus T1. I will just erase this small thing from here, and I will rewrite it this. Let me quick explain you what is happening. First of all, the metallic wire's length was increased. That was L1, and at that time the temperature was okay. Fine. Then you just have to understand that what is happening. That is why and all. Okay, this is how we will solve it. Okay.